Hi there, I'm Patrick Donegan with Stance. Welcome to a new series in TrustTalks conversations on cybersecurity and the telecom sector with AdaptiveMobile Security. I am here today for the first of this series with Graham Coffey. Graham is Head of Marketing at AdaptiveMobile Security, and also with Silke Holtmanns. Silke is Head of 5G Security Research. We have a terrific lineup for you today, running about 25-30 minutes, we expect. We're going to begin with a 3-minute or so update on AdaptiveMobile Security, letting you know what they're up to, what their momentum is in the market. We're then going to turn to the main feature today, which is the recent extensive research that AdaptiveMobile Security has done on 5G network slicing and some security vulnerabilities that have been discovered. We're then going to move on to some other subject matters which relate to some SMS hijacking issues that have been discovered, and also a vulnerability in the hardware and software of Accellion, a content firewall vendor, which has impacted at least one major telco that we know of. So with that, let's turn to the first part of the show. So to the first item on the agenda, a quick look at some of the big ticket items, some of the big events in the world of AdaptiveMobile Security, the company. And for that, Graham, I'm going to hand over to you.
It's been a very busy quarter one for us, following on from a great company performance in 2020. Quarter one this year has continued that trajectory for us, and we're very pleased to see our security footprint is growing in different markets. We've added 4 new customers in quarter one, which we're all excited about. Everyone will have seen the press announcement regarding the research project with the Department of Homeland Security Science and Technology Division in the USA. That's super cool for the company to be involved in that research project. Also, we're pleased to announce that we've been awarded a contract with Digicel to secure their Latin American and Caribbean operations as well. So again, another great new ad for the business. We've also expanded our sales team and sales presence in the Asia market with a new team being set up in Japan, where the growing Japanese kind of customers in the last few years has been quite impressive, and it's the right time to make this commitment to the Japanese market and to our customers as well. So we have high hopes for success in the future for that team. Also, I guess the main reason we're here discussing today is to further discuss our 5G security slicing white paper, which Silke will discuss with yourself, Patrick, as we go forward.
So that's great to hear, Graham. Good to hear about good momentum in South America and Japan. Good to hear as well that you've had what sounds like a very good year in 2020, which was a difficult year for a lot of businesses, let's face it. Let's now move to the second part of the agenda, which is the real meat of today's session, and that's speaking to the research that Silke and her team have been doing on network slicing for 5G. Let's bear in mind just how much of the industry's hopes are pinned on the ability of network slicing to offer differentiated services to enterprise customers. So Silke has done some phenomenal research, produced a 35-page white paper detailing a number of vulnerabilities that she and her team have discovered in the network slicing standards. So Silke, tell us to start with, what did you find from your research? What are the top-level takeaways?
Thanks for the introduction. We started by studying exactly how slicing is specified in 3GPP specifications and then we combined it with known hacking approaches as well known by OWASP from the IT environment, because 5G uses a lot of web protocols. So we wanted to see if the known approaches in the IT environment could also potentially be applied to the telecommunications environment. And while we studied that based on the existing specifications, we noted that things like location tracking and service theft and denial of service for parts of the network are potentially possible in a let's say, typical deployment environment, or what we consider a typical deployment environment.
Right. And now, just briefly tell us, if you would, what sort of methodology did you use for? I mean, you've described it at a high level, but what sort of detailed methodology did you use to undertake this research?
So basically, we started at the OWASP, the top 10 OWASP, and looking, okay, what are the most likely things that could go wrong?
Mm-hmm.
And 5G is a very complex system, much more complex than 4G. Even without the legacy and roaming, it's much more complex. So, and therefore we're thinking these are the typical things that we would believe go wrong. Configuration is one thing, and the other is authorization, or broken authorization. So, and then we studied, okay, how does authorization inside the core network works in a slicing scenario where some things are shared and some things are not shared, because this is very often shared resources are very often the source of problems, that then actually the access is not correctly configured and things are exposed. This is happening basically every day on the internet, and something very typical. Then you share things with your partners, access control is not set right. The next things happen is that the data leaks. And therefore that was a scenario where we're thinking, okay, happens very often, so this is probably an area where it's worth looking at. And then we started pinning down how does slicing security exactly works inside the network, because the part where the user is assigned to the right slice, this is very well defined, because this is a very typical attack scenario for 3GPP. But the things where actually a partner is a potential attacker, this is still somewhat not properly considered by 3GPP, or not fully considered. So they introduced some methods, but it's still sort of, how should I call that, not fully embraced, that you really need to consider that your partners might actually be attackers. So.
Right. So then let's take each of those three vulnerabilities that you identified in your research and drill down into each one. Let's look first of all at user data extraction and specifically location tracking. What did you discover, and how do you think that might be mitigated?
The location tracking attack is actually just an example attack. It can be any service that is user specific. And in this attack, basically, we showed, or we outlined, how one vertical, so one external partner, could track a user from another partner. So, and there the main problem was the granularity of authorization, so that it's not specified actually. It's specified that one company can use a service, but it's not specified, not cross-checked with the user identity. It's actually really allowed to request a service for this user, which leads to that, for example, if I own one company, I would be authorized to use a service from my own location, but I would just stuff in your identity and I would get your location, because there's no checking between, okay, the service is for me, but is it really my identity that goes into the API? So I could just sneak in another identity into the API. So that's basically the underlying problem. So, and this kind of identity check with the slice identity, so this kind of cross-matching of information is not taking place. It's not specified. So it might be that if everything is from one vendor, that there are some proprietary things, but they're at least not specified. And if you have the situation that the network is part from that vendor, then you need to specify these kind of things, else they are not there.
Okay. Let's then also look at denial of service attacks, because obviously that's a big concern for telcos already today. When you move into billions of IoT things, that risk obviously becomes greater and greater. What did you discover in terms of the potential exposure to network slices to DDoS attacks?
Yeah, DDoS attacks are potentially more interesting in 5G, because some network operators also have government customers, and therefore denial of service becomes really an issue, in the sense that if one vertical or one external customer partner runs a denial of service attack against another partner, though that partner might be actually sort of some sort of critical. So while today denial of service is not against the whole group, but would only be potentially against one single user or something. So the scope changes in that, sort of just as a preamble. And the other thing is how it works is basically that 3GPP has a feature for overload control, which is important because all the nodes can talk to each other. So you want somehow to control that not accidentally some overloads happening. So there's a feature, it's overload control indicator. Let's say it's a sort of do not disturb feature. Basically, one node is telling the other node, please don't disturb me for a while. I'm a bit busy right now. And in 5G, this is a header. And you can just put it on top of any message. So when you send a normal message, it has basically a little tag, a little header, and saying, please do not disturb me for that time. But this tag or this header is not cross-checked actually with the sender identity.
Okay.
So I could put a do not disturb sign basically for you. And since there's no cross-checking, you wouldn't be contacted with notification or other messages. So basically the nodes wouldn't talk to each other for some while. So they would just use the cache data. And if you launch during that time another attack, it gives you some sort of cover against detection. And
in terms of fixes, what type of fix should we be looking for, would you say? There are several types of fixes. Of course, there is the parts needed for interoperability, which means the authorization token should be fine enough and the granularity should be good enough to include slice identities, instance IDs, or other items. And then there's this cross-checking, which also would need to specify it. In GSMA, we just contributed some improvements to the GSMA document so that slice identities are not easily guessable, because in the moment it's this kind of slice, let's say for IoT, and then you have basically an identifier which the operator can define themselves, and most likely, I suppose most operator would just put the name of their partner there, which you can get from a press release, which makes it easy for an attacker, because then he knows, okay, that's the identity I can use. So we propose to use a random identifier there, and also make sure that that actually these kind of cannot be brute forced. So there are these kind of standardized parts. Some of these things are easy to do, like changing the identifier to be random. Some are a bit more difficult for this kind of cross-checking. You would also need to have the right information in the right place to do the cross-checking, which might be a bit challenging. So this is basically 3GPP tasks. And let's see how long that takes. I hope it's done in release 17, which would mean somewhere late next year. And then, but that still it's not solving everything. This is not a silver bullet, because now we talk about fixing that would take roughly a year, and then maybe a bit more for really the products to be up to date. So which means that's quite a long while for real deployments. In the moment, we are in the convenient situation that the deployments out there are mostly proof of concept type, so they're probably not 100% standards compliant. There are just a few partners, but we also need to think forward in, let's say, 3 years, 4 years. If we discover then something like this or similar issues, we cannot wait 1.5 years to fix something. So you need to monitor the traffic. And also it's important to understand that the attacks coming from partners. So meaning 99% of the traffic is perfectly okay. It's wanted. I mean, you want to make business with those guys, but there might be just a little bit that's not wanted, and your partner might not be even aware of it. They might be compromised themselves. Other reasons, and you don't want to block your best partner because of this. I mean, this is very typical also. We see this in roaming. They are the same issues. I mean, you don't want to sort of stop people from making business. So you need to monitor
TLS is not enough.
Right. Okay, let's look at the last vulnerability then, the last major one, the ability for undesirable people to access a network function in someone's slice, which we obviously would not want. How did you discover that this was plausible?
Yes, basically, when you request an authorization ticket, which basically is your entrance ticket to a service, this is not really well specified, which means that everybody can ask for any kind of ticket.
Mm-hmm.
So, which means for a shared network function, I could ask, let's say I just put in the service request where I request the ticket, I would just put your identity in there and then I would get the ticket for you. So, which would allow impersonation, and depending on the how the operator handles and customer might even lead to fraud, because of course the user or the customer has to pay per service. So depending on what the service is, if it's already in the contract or not, so this might encourage some fraud, which is not good.
Right. So at the risk of inviting some, introducing some industry cliches, which I think are nevertheless useful from a conceptual perspective, could we say across some of these vulnerabilities that you've discovered that the environment, the 5G core environment as defined thus far, has too much trust in it, and that we need to move to less trust, if not zero trust?
Yeah, the zero trust is usually very often associated that all the nodes just talk TLS or VPN to each other and use OAuth. But as we saw, this is not enough for really sort of having real deep trust. You need to monitor. You need to check what's going on.
Right.
As said, it's potentially the partners that attack you and or are compromised. So you really need to look into it also to see that the service level agreements are enforced. So, and also if you notice something, you can react faster. So yeah, it's a trust issue and also the granularity of trust. So it's not enough just to know your partner. Okay, this is my partner, it's okay. You really need to dive deeper.
Right. And let me just put this to you, that one can take two extremely different perspectives on the work that you've done and the discoveries you've made. On the one hand, one can go, oh my God, they found a vulnerability in 5G. They told us it was incredibly secure. It's not. Oh my God, what a disaster. Alternatively, one can take the view that says, look, slicing isn't even commercially up and running yet. They've discovered vulnerabilities ahead of time. That's an absolutely terrific thing. The industry should congratulate itself. Where do you sit on that sort of scale?
Well, usually in the middle.
Usually in the middle, right?
No, seriously. I mean, it would be good if this would even be sort of considered before, and if I wouldn't have found it, it would have been best in the sense for the security of the system. But it's positive that we found it before each operator has 20 partners and they have deployments running, and potentially some fraud has already happened. So
absolutely.
And then they are suddenly in the news and nobody wants to be there. So it's good. It's the right time we found it, but it would have been better, of course, if it wouldn't have happened at all. But on the other hand, I know how 3GPP standards are written. The security guys are in the inconvenient position that they're usually the last to finish up their job, because architectures and protocols need to be sort of stable before they can apply security to it. So which means they usually work under huge pressure. So I'm not really surprised that this kind of, let's say, oversight has happened. And I'm pretty sure they will take care of parts of it. But as said, they cannot do everything. There are limits to what you can do with a specification. So so let's see.
And then a last question, if I may. So I think I'm right in saying that you submitted these findings to the GSMA's CVD program, I think, in February. What would you say is the approximate outlook or timeline for evaluation of these issues and potential finding effects for them within, be it 3GPP or GSMA, whichever?
GSMA reacted quite fast, so we reviewed the vulnerabilities quite quickly, but we wanted also to go public quite fast, so that also sort of our customers and 3GPP have the information basically freely available. So we hope that 3GPP tackled this in release 17. I said that somewhere next year. For GSMA, we already provided the change request, and they are in the moment in the formal approval process. So this is ongoing. So things directly related to what the standards body can do are on the way. Let's call it that way. But as said, this can only be part of the security system for 5G.
Great. So let's move to the third segment, the one that's what's going on out there. What else is going on out there? And let's look first of all, Silke, at a new technique found for SMS hijacking. A new technique has been found for hijacking someone's SMS messages. It's one that's quite a bit more straightforward than a SIM swap or SS7 techniques that we're all familiar with, but potentially just as effective. So the attacker here chose a journalist at Motherboard, the investigative news site, as their target, and that ensured, obviously, from the attacker's point of view, that the attack was written up and published straight away into the bargain. So what did this attacker do? He simply went, believe this or not, to an SMS marketing services company, an outfit called Sakari, paid them the sum of $16, signed a letter of authorization saying they were authorized to receive the Motherboard journalist text messages. And believe it or not, that was good enough authentication. There was no verification of any kind with the actual account holder. Bingo! Text messages, including two-factor authentication messages, started being routed to that hacker, allowing him to tack into the Motherboard journalist's Bumble, Postmates, and WhatsApp accounts. Pretty grim one, this. Silke, what can we learn about this from the perspective of the telecom sector and the responsibility or otherwise, and other organizations potentially, for telcos to do something about this? So what are the learnings for the telecom sector from this one, Silke?
So let me first give a bit of background on this SMS interception attack. And it's North American specific, even if this is technology used, SMS is used all over the world. This is very North American specific because there are some specifics in North America, like different mobile standards, local number portabilities, and text enablement for 800 toll-free numbers. So they have some stuff, let's say, legacy. Yeah. And they don't throw it away, of course, nobody's doing that. And for that to interoperate with each other and to be able to do things like routing, they have added layers of complexity, databases, look up things, and so on. And there has been a whole new ecosystem being evolved around these kind of services to enable basically that the thing works. So, which also means from a learning point of perspective that legacy is going to stay around. One big important learning there. The other thing is that the ecosystem is getting more and more complex. Complexity is always bad for security, as everybody knows. And which means because very often it's also then not clear the responsibilities. Who should do what? Which kind of checks take place at which part of the process? And I think that's actually where this the attack that we saw basically failed. There were assumptions about who is doing which kind of check, which obviously didn't take place. And while service level agreements are something very useful and something very good, I think, as my mom used to say, sort of, yeah, trust it good, but you should check once in a while. So I think this holds very particularly. The more complex an ecosystem gets and the more different you have chained companies and doing different things and you have different service level agreement, it's a good idea to check what's going on, because at some point something might not be done properly for whatever reasons, because maybe they just thought the other guys were doing it or something. And this is very important, for example, for the multi-access edge computing, this kind of learning, because this is something where you will have then application developers that develop things for the multi-access edge computing, and the MAC, the multi-access edge computing, then goes to the core network. So you here also have a chain, and these kind of cases, you need to be absolutely clear who has to do which kind of background check.
Yeah.
Because in the end, what one entity is doing might affect then the other end of the network. So, and I think that's exactly what we saw happening there. So this kind of complex ecosystem, and everybody's assuming that everybody's just behaving as they should.
Yes.
Which is sometimes not true.
Of course, yeah. So I think a couple of things there. I think certainly we should recognize that you mentioned it was an incident that occurred in North America, in the US, I think, and those carriers did block that vulnerability within a pretty short time. And I think we should recognize that and give credit for that.
Yeah, they did.
The other point is when you refer to it's North American specific, and you refer to there's a lot of complexity in this whole ecosystem of wholesalers, resellers, marketing organizations, and goodness knows what. Yes, it was specific to the US, but actually that ecosystem of wholesalers, resellers, and marketers is the same all over the world. Even though there's a specific flavor in the US, there are other flavors elsewhere, right?
Yes, of course. I mean, everybody probably knows these kind of reminders from the dentist, getting an SMS, something, or getting some information from, in the moment, Corona is very popular. Of course, that you have your confirmation for your appointment or claim your benefits or whatever. And this has been misused
You're
by
referring to smishing attacks.
Yeah, exactly. So which
phishing,
shows that this is just, as everybody goes virtual, that's also true for the attackers.
right.
So
yeah,
they just try to find, and they come up with ideas you haven't thought about. So and they keep up with the times. I mean, today it's confirm your appointment or something, and maybe then in, let's say, 2 months, it get your appointment for your second shot. So
let's maybe take a last point on this issue in terms of the resolution of the missing pieces of authentication within that whole SMS services ecosystem. There are telcos, there are the wholesalers and resellers themselves, there are regulators. To what extent does the responsibility lie with the telcos themselves, and to what extent should we expect others to play their part?
I suppose that regulators for sure will also have a say on that. I mean, in the US, we saw things like robocalls, which also reflect somehow in the SMS space, because the telecommunication providers, they are in the end the ones that hold the data. So they have hands on the data, and they need to validate where the things are coming from, which is sometimes a bit challenging because you have alternatives access from the internet. You can send an SMS from the internet. So basically, but they need to support the technology to be able to say, okay, with this one, I'm absolutely sure this is coming from this number. And with this, probably it's coming from that number, but I'm not 100% sure.
Right. Okay.
So basically introducing different security levels, and also different security zones, in the sense that, these are really trusted partners where I can absolutely trust that they will not send me any malware or any sort of unwanted messages in the widest term. So, and these are the ones I've seen strange things from them in the past, so maybe they are not that trustworthy. Right. So in this kind of mix of security zonings, this is something which is slowly evolving in the telco environment, in the telco ecosystem. We saw that with 5G when they introduced the security edge protection proxy, which is basically a 5G signaling firewall. So they started doing that, but I think there's still a lot of more work to be done on that area, because the security zones need to be much more smaller and more fine-grained than they are in the moment. So, but it's a step in the right direction.
Very good. So second now, in terms of what else is going on out there, let's look at the breach over at Accellion, which is a vendor of content, firewall hardware and software. They had a breach that exploited zero-day vulnerabilities discovered on its on-premises file transfer appliance, a so-called FTA. The reason we're mentioning it is that among the many victims, unfortunately, was Singtel. Now, let's be clear, Singtel was one of just many victims. In fact, actually, one of the other victims was Qualys, which itself is a leading cybersecurity company. What do we know? We know from the March 12th statement that Singtel themselves made that the PII of 129,000 customers was compromised, bank account details of 28 former Singtel employees, and the credit card details of 45 staff of a corporate customer with Singtel mobile lines, according to Singtel's own statement. We do know that many of the victims of the Accellion data breach have been the subject of extortion by criminal gangs demanding a ransom and threatening that if the victim doesn't pay that ransom, they will expose that breached data. Should say, however, that Singtel themselves have not said anything about whether they themselves were the victims of such an extortion attempt. But this is an important breach in the sense it's an enterprise security vulnerability that a telco has fallen vulnerable to rather than a telecom ecosystem vulnerability. But it's caused a lot of pain for Singtel, Silke. So what can we draw from that as a lesson for the telecom operator market?
This incident became public somewhere in February, but if you look at the timeline, actually it started a bit earlier. It started already in December. And Singtel actually it sort of worked very closely with the vendors sort of to try to patch it as fast as possible, but that didn't exactly work as they wanted. And then basically they took the whole system offline. So, and also informed later on with a press release quite detailed about that, which I think is sort of a very positive approach to the, which is not always. We haven't seen all the other ones doing that, so I think sort of even if we mention them now, I would like also to sort of highlight that they did this actually handled this in a very positive manner. With now 5G, a lot of things are going to be virtualized. Operators are going to rely more and more heavily on cloud providers. We see also new players, cloud players coming into telco space with the virtualization, and there will be databases. I mean, all these operator nodes, most of them are just the big databases if you really boil it down to it. So, and those databases, it's easy to make a configuration mistake and then put them on the internet, especially if you have something on it which should be shared between some nodes or something. So I've myself seen in an IoT search engine, I found databases from operators which had this nice statement, read this first, which means basically they were ransomware. So these kind of things do happen. And I think with this kind of outsourcing trend and heavy usage of cloud, it's just a one-liner mistake to make. And then the database ends up on the internet and then something happens. So I think it's very important to have this kind of penetration testing and constant checking, especially with regard to configuration. And 5G is complex. It will require much, much more configuration than previous 4Gs. Not that 4G was easy, but so 5G will be much more complex because you have much more parties in there. So we need to be prepared also for these kind of incidents to happen. And I don't think then it boils down how you deal with these things. Right. Do you have a backup plan? Do you have backups? Are they clean? Have you done your pen testing homework? Things like that. Have you done monitoring of your service level agreements? All these things become then important, which are already today daily bread of IT. So, yeah. So fantastic. That will be the future for us.
So thanks very much, Silke. And, if I look back on the conversations we've had over the last sort of, 30 minutes or so, the theme that has arisen time and time again is constant checking. And that, I think, is where we need to get to as an industry and as a telecom sector in particular. It's really all about the constant checking. It's not accepting that what was okay 30 seconds ago or 10 seconds ago is still okay. It's validating that on a constant basis. So I think that's really been really worth understanding today. Graham, Silke, thank you very much indeed. Silke, I think you have some announcement to make in terms of deliverables that are available.
Thanks for the good discussion. I really enjoyed it. So yes, brief announcement. we have a white paper on slicing security, on 5G slicing security. And it's also a tutorial on how slicing security really works down to the detail. Of course, you can read 500 pages of specification, but I suggested the 35, even if not light reading, might be slightly easier than reading 3GPP specifications. So we also have white papers on security migration from 4G to 5G and other interesting papers available, so for download.
Thank you,
Thanks a lot.
Silke. You have been watching the first in a series of Trust Talks on cybersecurity and the telecom sector with AdaptiveMobile Security. It's been terrific. We look forward to our second edition, which we expect will be in the June timeframe. Do please look out for that, and hopefully see you then.